All right, this is the statistical graphs section from Triola's book, and we're going to be talking about an ogive, which is a graph made from a cumulative frequency table. So in a cumulative frequency table, we had the counts, and you remember with the way that Triola's book does a cumulative frequency is that we use the upper class limits, and we say less than the upper class limit. And then I also told you that some books choose to use the boundaries to make a cumulative frequency table. And it's a little bit of a combination between the upper class limits and the upper class and the idea of the boundaries that creates an ogive. So with an ogive, what we're going to do is put the cumulative counts on the upper boundaries. So the lowest lower class boundary is 15.5, and that would be where we would have this count of 0. So we would put 0 down here. And then at 24.5, we would have a count of 3. And so at 24.5, we have a 3. And then the next one added 4 to that, so then we would have 7 at our next upper class boundary, which is 33.5. And essentially what this is saying is that for less than 24.5, we have 3 individuals, and for less than 33.5, we have 7 individuals. And then the next one, we added 2 more, so at that point in time we had 9. So at 42, less than 42.5, we have 9 individuals. And then at 51.5, less than 51.5, we have all 10 individuals. And so that's what the ogive looks like. And when we go ahead and we draw this, what we see here is that we are kind of tapering off, right? A steep climb, a little bit steeper, and then tapering off a little bit. And the ogive there therefore tells us where we have the amount of steepest increase, whereas we're flattening off in our increase. And that's exactly what we talked about when we did see the cumulative frequency distribution in section 2.2. Now the next thing that we want to talk about is a stem and leaf plot, or just sometimes called a stem plot. Now the benefits of a stem and leaf plotter is that it gives us the original ordered data. It shows us the shape. It's easy to create if we know expanded notation and the type of data. In other words, when I talk about type of data, I mean, is it discrete, is it continuous, what are the units of that it's continuous to, etc. And outliers are really easy to see. Now everywhere I've put a star here, these are the things that make the stem and leaf a superior way of seeing the shape of the data as compared, for instance, to a histogram. So the first thing we need to talk about is the purse snatcher data in terms of the type of data we have. So remember, we had 16, and then we had 17-year-olds, and then we had a 21-year-old and a 25-year-old and a 29-year-old and a couple of 30-year-olds and then a 41-year-old and it was 39-year-old and then a 41-year-old and then that 50-year-old. And so what we see is all within the families of 10s, 20s, 30s, 40s, and 50s. And so it's those families, those groupings of 10s, the way we read our numbers, that's going to show our expanded notation. And so we're going to look at having stems that represent the 10s and the 20s and the 30s and the 40s and the 50s. And then we're going to put those together with the ones units in order to form expanded notation. So we have 16 being equal to 10 plus 6. And that gives us the stem and the leaf idea. And that's how you create a stem and leaf plot, is with a stem and a leaf, and you tell the units. With that said, that's how we're going to go ahead and make one of these stem and leaf plots. So I'm going to go on to the next page here, and I'm going to show you that we can have a couple of different types of stem and leaves. We could have an expanded stem and leaf, and we have a condensed stem and leaf. Now when we make an expanded stem and leaf, we're spreading data out a little ways that is all in a very close, compact area where we may have quite a bit of data. So what we have to do is with every stem, we have to have an equal amount of leaves. So we can have 2 stems, 5 stems, or 10 stems because we have 10 digits that we can spread evenly over those. So the number of digits, 10, divided by 2 is 5 per stem, and divided by 5 is 2 per stem, or 10 stems, which is 1 per stem. And they must be evenly distributed. The digits 0 through 9 must be evenly distributed throughout the stems so that we don't mess up the shape of our data. So that's one of the options for doing an expanded stem and leaf. Now a condensed stem and leaf, which I don't spend any time really focusing on, if you want to see an example of a condensed stem and leaf, look at the exercise set on page 70 of your textbook. And these have multiple families per stem. So we may have 10s through a 20s in one stem. So we may have a 10 and a 20, and then a 30 and 40s, and then 50s and 60s, or so on and so forth. And so this is where we may have data that's spread over a long range, but have a small amount of data. That's when we use a condensed stem and leaf. So for our data with an expanded, here's an expanded stem and leaf for our data with use of 2 stems. So in the first stem, we would use a 0 through 4, and then in the second stems, you use the digits 5 through 9. And so that you see that puts in 0s, 1s, 2s, 3s, or 4s. That's 5 different ones. And in the second grouping, you have 5, 6, 7, 8, or 9, and that again is 5 different digits. So if we are looking at our data here, we have a 16, a 16, a 17, and then a 21. The only 2 we have in here are the 16 and the 17. So in this first digit right here, this first one, there wouldn't be any digits in there, and we would simply be putting in the 6 and the 7 here. Now, because there is no data in that first one, we actually should not put it in. Anytime the first stem doesn't have any data, you don't use one there. So we would just use the 1, 1. And then our next one is 21, and then we have 25 and 29. Well, this is the only number in the 1s through the 0 through the 4 range. So we're going to put a 1 right under here underneath the 6. And then the 25 and the 29, those are in the 5 to 9 range, so they'll go in our second 2. So we're going to put a 5 in here and a 9 in here. Now you'll see that these line up under one another, and then this second column lines up. And it's really important that we keep columns here. Now it doesn't have to be all 1s and then all 2s and all, that's not the case. It's just this first number here and then the second number here. There's only 1 here, so it lines up under the first one here. The 2 here lines up under the first and then lines up under the second one here. Then our next 2 numbers, we had 30s, and then we had a 39, right? So these 2 30s are in the 0 through 4s, so we're going to put in 2. Now, because we have 2 30s, you actually have to put in 2 zeros. And then the 9, it goes in the 5 through 9 range, so it goes with the second 3. And then our next one is the 41, and then the next one is 50. So the only one we have here is 41. So we're going to put a 1 in here, and then there are no digits in the 5 through 9s. But this, even though it's blank, we're going to leave it in there. When it's in between and you have a blank one, you always have to leave them. And then our next one is a 50, so this is going to go right in here. And then, because this one, you see this 50 down here, or this 5 down here, where the 5 through 9 range goes, it's blank, so we're not going to use it. So if it's on the top end or the bottom end of a stem and leaf, they're blank, then we don't use them. However, if they're in the middle like this one, we leave it blank. Now the problem with expanded stem and leaf here is we have a really small amount of data, and so expanding it like this isn't showing us the shape of the data maybe as much as we would want it to. So I'm going to show you the regular stem and leaf for the purse snatcher data and how it would look. Now, of course, I would definitely want to give this a title, right? So I would say in this, because the stems and leaves, there's not really any room for the units, I would want to title this as the ages of purse snatchers in years. And I always want to put in the units for my stems and the units for my leaves so my readers have an easy time of reading this. So I'm going to have one single stem for the 10s, the 20s, the 30s, the 40s, and the 50s. One single one this time. So they have the possibility of being 0 through 9 digits, or digits 0 through 9. So we have 16 and 17, and those are going to go in here like this. So there's 6 and 7. So you put this together. This is 10 plus 6, which is 16. 10 plus 7, which is 17. Then we have 21, 25, and 29. So 1 here goes under the 6. 5 here goes under the 7, and then the 9 goes over here. Then in the 30s, I have 30, 30, 39. So I'm going to put in 0 underneath the 6 and the 1, a 0 underneath the 7 and the 5, and then a 9 underneath the 9. And then in the 40s, I only have the 1, so I'll put the 1 here. And then the 50, I only have the 1, so I'll put it underneath here. So now you see even more so. If you tilted this on its side, you could see, right, the shape here. So let me just kind of draw that in with the blue pen here. So you see the shape as it goes there. You can see the shape a little bit here, but it's not as prevalent. Now the nice thing about expanding this out is you do see the gap between the 41 and the 50. And even though it's a small gap, it shows that this 50 is a little bit far out there as compared to this one. It doesn't show that outlier quite as well, but we're seeing that there's a little distance in here if we look a little bit deeper. So that's a stem and leaf, and this is an example of an expanded stem and leaf, and this would not be appropriate. We really wouldn't want to use this stem and leaf at all for our purse snatcher data because it's not enough data and it's really not spread over or can kind of grouped around a little area and a big amount of data. So just a regular old stem and leaf will do just fine, just like this. Now, the next thing that we want to talk about really briefly is a dot plot.